Alright, we finish up section 8.5 with an example of an application of a system of inequalities in two variables. And I have a very basic one. Now in section 6 we'll get into more of a business aspect of themes by looking at some linear programming, but this will be our first real a good example of writing the inequalities and then graphing them. So we read the example here. A family plans to spend 2 8-hour days at Disney World and will split the time between the Magic Kingdom and Epcot Center. If we let X represent the number of hours spent at the Magic Kingdom and we let Y represent the number of hours spent at Epcot Center, we're going to set up two inequalities that indicates that the number of hours spent at the Magic Kingdom and the number of hours spent at the Epcot Center cannot be negative, which means essentially, since X is the number of hours at the Magic Kingdom, X can't be negative, it has to be greater than or equal to 0. And Y, which is the number of hours spent at Epcot, it can't be 0 as well, or it can't be negative as well, so we make it greater than or equal to 0, and that's all they're really looking for. If you looked at the set of axes that I have drawn over there, and you wondered maybe why did he spend so much of this graph here emphasizing quadrant 1? It's because in most examples where X and Y represent amounts, they're not going to be negative amounts, and we look at greater than or equal to 0 for both X and Y, which puts us in the first quadrant. Now, we're going to set up an inequality that indicates that the combined number of hours spent at the two parks is at most, means it can't be more than, it can be less than, but at most 16 hours. Well, the combined means that we're adding X plus Y, and it has to be less than or equal to 16 hours because of the 2 8-hour days. Now we have 1, 2, 3 inequalities. That's the system. And over here, as you can see in part C, we're going to graph this the solution set of the system of inequalities. Now, I'm going to kind of give you a word of advice. You don't want to do the shading for X is greater than or equal to 0 and Y is greater than or equal to 0. X is greater than or equal to 0 would be all of this half plane. Y is greater than or equal to 0 would be all of this half plane above the x-axis, and they would overlap right here. So since I know they overlap here, I'm not going to graph these inequalities, but I'm going to graph this guy, and I'm going to use the fact that it's going to be in quadrant 1. Now X plus Y less than or equal to 6, I write the related equation, X plus Y, 16, is equal to 16, and if I subtract X from both sides, I get Y is equal to the opposite of X plus 16. Well, that's a line that has slope, -1, and has y-intercept up here. Notice the scale on the X and Y axis up here at 16. And so not only is 0, 16 a point on it, but 16, 0 down here is also a point. So I get my straight edge here, and this is going to be a line that contains these 2 points, and it is going to be, because of the equal to there, a solid line. Now I went ahead and emphasized and drew the line all the way through because it is a line, but it's really in two half planes. We've got this half plane up here in the first quadrant, and then we've got this region right here in this quadrant. So I have to determine which side to shade. So I take a point that's not on this line, like 0, 0, go back to the inequality, X plus Y less than or equal to 16, plug in 0, 0, and I get 0 plus 0 is less than or equal to 16, 0 is less than or equal to 16. Well, that's a true statement. So when I go to shade this, I want to shade in the first quadrant to kind of down and to the left of this line that I have drawn. I'll use the red pen here. And that gets me this triangular region. Alright, and of course my phone rings right at that time. There we go. And that would be the solution set to that set of inequalities. Now we're going to do more complicated systems of inequalities in story problem form in section 8.6 on linear programming. But for now, practice, practice, practice.